Hello, my class 10 friends. We are going to solve the problems on work from class 10 physics. Now, I'm going to solve two questions. The two questions which normally like to come in the examinations. Before I begin, I just wanted to announce that my online course is nearly on the verge of getting published. So you'll keep looking in the description box. And if you want some more value from your physics, chemistry, and maths, then do consider subscribing to my channel. Okay. Let us come to the first question. This question probably is in your textbook, but you will see that many of these textbooks will have their questions taken into the examination paper. So this is the one which frequents many examination papers. So I decided to make a video out of that. A hydroelectric power station takes its water from a lake whose water level is at a height of 50 meters above the turbine. Now this height becomes your H. So I will write H equal to 50 meters. Assuming the overall efficiency of 40%, so we have been given efficiency. Calculate the mass of water. So this is what we have to find. Mass of water which must flow through the turbine each second to produce a power output of 1 megawatt. Take G as 10 meter per second square. Now when you solve any question, first thing you have to do is identify the quantities which are given. So we have efficiency. Now efficiency is denoted by Greek letter eta, which looks kind of like N, isn't it? Yeah. So this symbol stands for efficiency. Okay. So I'm writing efficiency is 40%. Calculate the mass of water. So mass of water will be found out, which must flow through the turbine each second. Now each second means even the time has been given as 1 second. And the power output is going to be 1 megawatt. And they are saying take G equal to 10 meter per second square. Now to begin with, let us look at our thinking step. Okay, our thinking step is going to start with what is given, and that is to be linked with what is to be found out. Okay, so what is the meaning of efficiency? Your efficiency is defined as output upon input, which means that it can be work output or power output, or work input or power input. So now in this case, we have to first consider the power is connected with work. How is it connected? Power is equal to work upon time. Correct? Yes. So we need to find out first what is the work. Now power output is given. That means power output, that is work output upon time, is given. Okay. Now power input will have to be connected with this efficiency, because efficiency is output upon it. So first thing we have to consider is finding the input. Now in order to find the input, we need to find out actually the power input. This is our first question. Okay, this is the hidden question. This is not given over here, but in order to connect with efficiency, we will need input power input. Okay, so what is power? Work upon time. So we need to find work input first. Now what is work input? Anytime anything is lifted from one level, lifted up to there through a vertical height of h. Remember, the work done is mgh. Always remember that. Okay. So, do we know how much water How much water was lifted up from here to here? We don't know. So that becomes M. Okay. What is G? The G value is given as 10. And how much is the height? The height is 50. Okay. So that becomes 500 M. These many joules. I'm writing joules here separately. Okay. So I will have therefore power input will be equal to work input upon time, which means it will be 500 M upon 1 second. Correct? Now, let me just draw a column here and I will continue here this side. So it becomes 500 M. This is joule. This is second. So unit wise we have got joule per second, which means we have got watt. So what is this? This is the power input. Now we have been given efficiency. So we need to connect what is known with what is unknown. So input has this M quantity which is unknown. So we are going to write efficiency is equal to power output upon power input. Now remember, this is how efficiency is defined. So can you see it's a fraction? So this efficiency, which is 40%, can you see this? This I'm going to write as 40 upon 100 as a fraction. How much is power output? The power output is 1 megawatt. See this 1 megawatt? Is it an SI unit? No. So we have to make it as 10 to the power 6 watt. Then it becomes an SI unit. So 10 to the power 6 watts and divided by power input, which is 500 M. Okay. So we will write 500 M equal to 10 to the power 6 into 100 upon 40. Correct? This has gone that side. Yeah. So it became 100 upon 40. Yeah. So M will be equal to 10 to the power 6. So I'm going to write here 6 zeros. Okay. Multiplied by 100 and that is divided by 40. And this 500 comes here. So it will be in the denominator. So let us see 1, 2, 3 zeros. 1, 2, 3 zeros cancelled. Correct? Yes. Now 5 ones. 5 twos 10 and 1, 2, 3, 4 zeros. Then we will have, I'll just change the color, 4 ones and here it goes 4 5s 20 and 1, 2, 3 zeros. Okay, so that gives us 5,000 kgs. So what are we going to say? That through the turbine each second, there should be 5,000 kgs of water flowing. And that is our answer. Alright, let's come to the second question. We come to question number 2. The bob of a simple pendulum is imparted a velocity of 5 meters per second when it is at its mean position. So, to what maximum vertical height will it rise on reaching its extreme position if 60% of its energy is lost in overcoming the friction of air? Take G equal to 10 meter per second square. Now, in order to understand this question, always you must have a diagram to help you. Let us say this is the bob of the pendulum. Okay. Now, this is the mean position. At the mean position, the velocity is 5 meter per second. Now, this velocity is going to make it to reach this extreme and then it will start swinging. Correct? So, when it comes to the extreme position, because of this velocity, it will have kinetic energy. And when it comes from this point to this point over here, it has acquired a certain height from here to here. Remember, the height is always taken from the center of gravity. Okay. So this is the height, and because of this height, it will acquire potential energy. But as it is moving from here to here, it is going to overcome the friction of the air. And because of that, how much energy is lost? 60% energy is lost. Which means how much energy is available for this potential energy? So you'll have kinetic energy becoming potential energy, and in doing so, 60% is lost. So it will have 40% becoming potential energy. And this is the important step. So we will say that the velocity is 5 meter per second, and that is at the mean position. Okay, and now it is going to acquire height at the extreme position. So they are asking you height at extreme position is going to be how much? What else we know? We also know that 60% energy is lost. So energy lost is going to be 60%. And G is given as 10 meter per second square. So we are going to say that if energy lost is 60%, so you will say that the potential energy at the extreme position will be equal to 40% of kinetic energy at mean position. Correct? So, potential energy, what is the formula for potential energy? It is mgh. And that will be equal to 40% of kinetic energy. What is the formula for kinetic energy? Correct? Did we understand up to here? Okay. Now, mgh equals, now we have to start calculate. So 40% we can't write like this. We have to write 40% means 40 upon 100. Correct? Multiplied by half mv square. Now m and m got cancelled. How much is the value of g? How much is the value of h? We do not know. 40 upon 100 as it is. Multiplied by half. Multiplied by how much is the velocity? Look over here. How much is the velocity? 5. So we will not write 25. We'll just write 5 into 5. Okay. So this gets cancelled. 2 ones and 2 twos. 2 ones, 2 fives, 5 ones, 5 ones. So h is equal to 5 and this 10 comes here. So it divides. So that will be 0.5 meter. And that is our answer. So we have understood the two questions which are very, very popular questions with the examiner. Alright, so if you solve it this way, you will get your full marks. So you will have your full marks, and that is what is important. So if you want to know about different topics in physics, chemistry, maths, how you get full marks, you should look out in the description box for the link for my online course. Okay? In the meantime, stay safe and stay healthy. Bye.